Welcome to the National Gypsum webinar series. My name is Scott Hughes. I am the Construction Design Manager for the Northeast and Mid-Atlantic states. Joining me today is Thad Goodman. He is also a Construction Design Manager, and he covers our Midwest states. And together we are going to present our newest program, Best Practices, Fire and Sound Solutions by Building Type. We really do appreciate you giving us an hour of your time, but a few quick housekeeping items before we jump into the program. Number one, you are in listen-only mode. So if you do have questions, please feel free to use our Q&A to post your questions. If we don't have time today to get to your answers, we are going to send a follow-up email or a phone call to you to make sure your answers are taken care of, or your questions are taken care of. If you are on a cell phone or a landline, in other words, if you're registering on this as a phone number, we don't know who you are. So we do need you to put into the Q&A your name, email address, and of course, AIA number would help just to filter through everything. So be sure to do that if you're not on your computer. And again, we are going to have a recorded version of this available with a follow-up email. So there will be a link to that. And with that, it's time to get started. So our program today offers one health, safety, welfare credit, and of course is approved by AIA. And we will provide certificates to everyone that we have an email address for. The program is copyrighted, so we do ask no pictures, no recording on your own of the program. But again, we are going to send out a link to a recorded version of this for folks maybe that you think should see it that aren't on the call today. Wanted to briefly introduce our team to you. We know we've got folks from all around the country, so I'll go around the United States starting with me. So I'm in the upper right-hand corner there. I have all the Mid-Atlantic Northeast states. Next to me there on the left is Thad Goodman, my co-host today. Thad covers the Midwest. You see the MWA there as well as the CEA states. To the left on the West Coast is Pat Grotlish. She has quite a big geography, but she's been around for a good time with us and does a great job for us on the West Coast. Jordy Polk is down there kind of by herself on the left, but boy, she's a big asset to our team and all that she does for us and with reaching out to architectural firms, lead submittals, and that's just a small portion of what she does. Right now, Texas area, SWA, we do not have a construction design manager, but we do have one coming very soon. So if you fall into those white states there, reach out to Thad or myself. We'll make sure that we get you the information you need. In the Southeast is Alan Zedek. Alan lives in Florida and covers those SEA, GUA states that you see there. And of course, does the same thing as we do. Last but not least, most importantly, Amy Hockett. She runs our department. She does a lot of other things as well, including manages our sustainable design things, documentation, and just the list goes on and on. So that's our team. The way to find us is nationalgypsum.com/expert-connection. And again, we're going to send this to you in an email when we follow up with you later on after the program. So you'll have all of this information and ways to get a hold of us. But we should introduce you to who National Gypsum is. We've got 3 building products divisions under the name National Gypsum. Gold Bond Building Products are all our drywall, gypsum board related things, including quarries and paper plants, those kinds of things. So anything yellow there would be related to gypsum board. Proform is our joint compound, and you see a few red dots throughout the United States there. That's where our Proform joint compound plants are. And then we have Permabase, which is our cement board product. So we've got several offerings of that, and we'll talk about that at the very end. But you see the blue dots there. That's where our Permabase building product plants are. So we've got a wide net of plants and networks, and we can service the entire country via truck and rail. So as a brief background, I wanted to we'll jump right into the program. I'm going to start us out, and then Thad's going to pick up here in a little bit. But the 4 things we really want to get accomplished today is we want everyone to understand what STC is, what a hertz is, how you measure for STCs. We'll talk some other acoustic terms as well. But we need to, the focus today is really on 3 building types. So we're going to talk about STC ratings and fire ratings in the healthcare, the school or education, and multifamily realms. So that's really the focus of today's presentation. And of course, we need to make sure that you all can identify, what's appropriate for which one and what walls, and there's options, right? So we're going to go through a lot of options with you today. So the order of today, I'll start out with some design considerations. Whatever system we decide to use or assemblies we decide to put together, there are some commonalities that we need to think about. So we're going to go through all of that first. We're going to do an acoustics 200 level class, okay, a little bit more advanced than just an introductory, because we need to know the right terms to talk to our clients as well as, of course, our contractors with. And we'll talk about what some of these sound control strategies are, meaning there's a lot of things we do, not just pick the wall partition itself, but there's a lot of other things that we need to think about. So I'll go through those three things. Thad will take over at that point. He's going to introduce us into the healthcare, education, and multifamily realms, particularly the STC fire rating designs for those. He'll go through codes and third-party recommendations, and we'll wrap it up with some acoustical and fire ratings as well. As a gypsum manufacturer, I would say our technical department's number one question we get on a daily basis is probably UL related, right? It's something to do with a fire design. Can I do this? Can I do that? I've got a weird thing going on here. How do I handle that? But a close second, if not first place, is an acoustics question. So that has happened in the last 10 years. As the generations get older, people start to move from single family homes to townhomes or to condos. All of a sudden you've got neighbors. So actually acoustics is becoming very quickly our number one topic. It's important that we understand what the recommendations are, and we're going to kind of filter through the whole program talking about the recommendations from the various code agencies, from USGBC, a couple from AIA, those kinds of things. So we're going to walk you through a whole lot in the next 40 or 45 minutes or so. So design considerations, things we should think about, okay, no matter how we're going to attack our particular partition when it comes to fire and sound. When we combine the two, we can't just focus on one and not the other, right? So quieter environments are super important for what we all do for a living in the building construction industry. We need quiet spaces for people to work, learn, and live. But we can't take away from that, of course, life safety, fire protection. So we're going to kind of go back and forth between the two throughout the whole presentation. You will find in most of the assemblies in these three categories, we have 1 or 2 hour fire rated wall assemblies. So that's where we'll focus today. There, of course, are cases for 3 and 4 hour walls, but we just don't have time to go through everything. So a typical 1 hour wall is right here. It's the U460, the old U465 wall. It's also called V438, simple wall, right? Metal studs, 24 inches on center. We've got a layer of 5/8 type X gypsum board on either side, and that gives us our 1 hour fire rating. Now you'll notice that middle bullet point has cavity insulation. It's optional. It's optional for sound. You don't need it for the fire. So that's an important distinction. As we dig into the STCs, we're going to tell you, we want you to put insulation in. No worry about R value or anything like that. For the 2 hour wall, same thing. So the 2 hour wall, everything I said applies, except we're adding an additional layer of 5/8 type X drywall to both sides of this partition in order to pass the ASTM E119 fire test to get a 2 hour rating. So they're the two we're going to focus on. We'll talk about some double stud walls and staggered stud as well. So let's get into our terms and our concepts and do a little acoustics 200 level course. I'll spend a few minutes on each one of these bullet points. Some of them are easy, some of them not so much, and there's some gray areas. Sound is not black and white by any means. There's a lot to think of. That's why there's a whole industry of acoustical consultants, because there's a lot to think of. So let's spend a little bit of time on each one of these bullet points here. First is structure-borne sound. Think of a high heel shoe or a dress shoe that has a hard sole to it, walking across a tile floor or a wood floor, and the click, 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 click. That energy vibrates through the building itself, through the parts and pieces of the building, and that energy will transfer sound through it. Sound is vibrational energy. There's a lot more to it than that, but it's basically a vibrational energy. So we have to consider these types of things. We could specify the perfect STC fire rated wall assembly, but if we ignored the floor, we probably defeated everything we tried to do. So we're going to show you that as we go through. Airborne sound is what STCs measure. Okay, so it's all about, and right now it's me. I'm pushing air over my voice box. That vibrates. Vibrational energy is coming at you if we were in person directly, but now it comes through a microphone and speakers. And the speakers are vibrating, right? We all know speakers vibrate, right? Especially if you turn the volume up, you can actually see them vibrate. But that's what sends out the pressure wave. That pressure wave hits your eardrum, and your eardrum vibrates as well. The brain takes over from there, and that's as complicated as we'll get right now. But the whole goal of an STC is to reduce the sound transmission through the partition itself from one end or from one side to the other. That's what we're trying to do. The higher the STC, the more it does that. So a little bit, all right, 200 level, okay? So we measure sound in hertz. When we are born, provided everything was normal with the baby, babies hear a very wide range of sounds, from a very low sound, which would be 20 hertz. Think machinery sound, a low, dull hum, but really, really low. And then to as high as 20,000 hertz. Now that would be the most annoying sound you probably ever heard. If you listen to 20,000 hertz, it is a very high pitch, high pressure type sound, really high. I mean, as an adult, we can't make that noise. But as you get older, and it actually happens quickly into your adolescent years, we don't hear this wide range anymore. It shrinks down. And we're guessing on bullet point 3, 100 hertz at the low end to 8,000. Some of us can hear 10,000, maybe 12,000 hertz. But once you're in your 30s and 40s or older, it does shrink down to this range here. Speech, I'm told, is typically found in this 125 low end to high end 4,000 hertz range. So that's where STCs are measured. The point of this is, if we know we've got a machinery sound that's going to be 100 hertz or 80 hertz, your STC rating is useless. If you know you're going to have a piercing sound that's over 4,000 hertz, your STC rating is going to be useless. So we have to do other things to figure out how to attack those particular walls. So our focus today is in this middle range of 125 to 4,000 hertz. We all know decibels, so that's the easy one. That's the softball for today. There is no such thing as no sound. That does not exist. There's always sound, but as human beings, we don't hear some sounds, right? Dogs hear, we all know dog whistles, they hear it, we don't. So we have to have a reference point. So 0 decibels, for argument's sake, is no sound to an adult. The higher the decibels, the more the decibels increase, the louder the sound. It's a logarithmic scale though. So decibels 0 to 50 is not really hard to do. It's basically, I'm not talking and now I'm talking. So if we get to a 60 decibel, it's typical conversation between you and me sitting at a table across from each other. There's no reason to elevate a voice. Now, if I was presenting to all of you in an auditorium without a microphone, I'm obviously going to have to elevate my voice because the people in the back couldn't hear, because your bodies would absorb that sound. Better example is a conference room with 50 people in it. All those bodies are absorbing sound. I'm standing up at the front. I need to elevate my voice to 65, maybe 70 decibels so that the folks in the back can hear. If we look at the chart, once you get to about 100 decibels, if you're exposed to 100 decibels or more for too long, it can actually cause physical pain. So that would certainly be concerning. If you get a new iPhone and you plug in your earpods or your AirPods for the first time, there's this little warning comes up. Make sure you don't listen to too loud noises, because that will actually cause physical pain. So make sure you tell your kids and your grandkids that. Keep the noise level down. So a decibel change, a 1 to 2 point of decibel change is really not noticeable to an adult. Well, to anybody actually. So 1 to 2 decibels, your brain doesn't even think anything. Once you get to 3 to 5 decibel change, whether you're going up louder or down quieter, that's clearly noticeable. And look what happens at 10. We either double the sound if we go up 10, or we cut it in half if we go down 10. And then 20 is, 20 is brilliant. That's wonderful. If we can cut 4 times the sound, we're doing an awful lot. But our focus today with STCs really needs to be in that 3 to 10 range, right? Preferably the 5 to 10 range. If we can cut those decibels down with our partitions, now we're doing something as far as keeping rooms quiet. So that would be our goal. I can't tell you that increasing 5 points of STC is going to decrease you 5 points of decibels. I can't tell you that. There is a formula that's close, but it's not a one-for-one change. So it takes about 30 minutes to get through all of this so that we have a general understanding of how all this works together. Flanking sound is very similar to what we talked about earlier, my very first slide with our course, 200 level course here, with the building element sounds, where the vibrations from a dress shoe on wood floor kind of vibrating through. But there's other areas too. Think about the blue arrow that's coming up through the partition. That's outlets. If you've got air going through an outlet through the back, it's not pinched the wires aren't pinched perfectly in the back, and air can get through there. It can kind of seep through your wall to the other side. Well, obviously sound can get through there. So there's things that we're going to talk about that we'll do for our outlets. The floor itself, we could put an STC 75 wall, right? I'm throwing a number way too high out there. Bombs go off, you don't hear anything. But if I don't take care of that vibrational energy from one room to the other, it's a problem. So we've got to take all of these things into consideration as we decide what we're going to do, how we're going to build our fire rated STC wall. One way is stuffed flutes at the top. We can see some gaps there. If you see gaps, that means sound's going right through. This is the simplest way to do it. There are other products on the marketplace for sure, but this would be the simplest way to do it, to just stuff the gaps, Caulking. We talk about caulking, caulk everything and anything you can, because it will prevent sound from traveling through. It will prevent might not be the right word, reduce the chances of vibration from one building part to the other from vibrating through. My company does not sell sealants. We don't sell caulks. That's not why it's in the program. It's just that important to get the actual field value that we specify in our plan, right? So we have our partition schedule with an STC rating on it. We were hoping to get that in the field. Thad's going to address that here in just a few minutes. We probably aren't going to get the exact number, but caulking helps. So what is an STC? This is all comes down to this. Sound transmission class is a way for us to compare one wall assembly or one partition to another and how it will perform at various frequencies. So third octave testing is the bullet point number 2. Third octave testing takes frequencies between 125 hertz and 4,000 hertz, 3 notes on the scale. So if we have a piano keyboard in front of you and you hit middle C, you go C, then you go D, E, F, G, A, B. So every 3 notes starting at 125 hertz, ending at 4,000, that'll be 16 times. So when we test, we have this noise generation. It's all ASTM guideline, and it throws all these frequencies through our partition. And on the other side, there is a microphone that pulls all of that data in. Once it pulls all that data in, it's not an average, okay? It's a weighted average. It's not an average of all 16. It's a weighted average towards the lower end a little bit, and it spits out an STC number. So the higher the STC, the better, and obviously the lower the decibel, the better. So they're opposite. STC values are also logarithmic, and meaning a 40 STC rating to a 45 STC rating means nothing. It's a paper thin wall. We can have a conversation with each other through it. But 45 to 50, that's done a lot more than what 40 to 45 did. So the higher you go in number on STC, each point higher is doing more than the point before. So I talked about the noise generation. We build a 10 foot by 10 foot by 10 foot room, or a 12 by 12 by 12. We have a wall, and then we have another room on the other side, same size, 10 by 10 by 10 or 12 by 12 by 12. And they generate this noise through the wall. The microphone picks it up on the other side. It's a little more complicated than that, but for time, we'll just go with the general. And it's pulling all of these frequencies into the microphone at 120 decibels. So it's pretty noisy. I've actually witnessed these tests, of course, not from in the room, but from outside, and you can hear it pretty good. 120 decibels is loud. And they pull all of that. That's the E90. That's how you put the test together. The E4, I'm sorry. Yes, the E413 is how all that data is generated into a STC rating. We do need to mention real quick the CAC, which is the ceiling attenuation class. This is all about how do we keep the noise in a drop ceiling where the partition doesn't go all the way up to the deck, from bouncing up and down through the other. Now, the tiles are supposed to do a lot of that for sure. But let's say we have a job, it's all done. We've turned the keys over to the owner. 3 months later, they call and say, hey, everybody can hear in the next room because of the sound bouncing over. Well, the quick fix here is that 4 feet of insulation laid across the ceiling tile will fix that problem. Because if you're in the middle of the room, it's going to bounce up and come back in the room. But if you're towards the edge, right where the sound source box is, without that insulation, it can bounce up and come back. That does not violate any UL ratings. So that's a quick, easy solution. So that's what CAC is. So sound control strategies. Here are a couple ideas. Number one, eliminate the cause or source of the noise. Can't do that, right? Silly. Use materials that absorb sound. Yes, we can do that. So we want to do that. There's plenty of products out there that are soft fabrics that keep the NRC down, to keep the vibrational energy down within the room itself. If we can put expensive things out away from where all the folks are, not expensive things, noisy things out, that's the way we want to do it. Can't always do that. So we're going to do bullet point number 4, and we're going to concentrate on using the gypsum board itself and several products made for this reason to increase our STC ratings. We do this by adding mass. By adding mass, we use different materials. We want to use the softest stud possible. So wood studs don't perform very well. 25 gauge metal does. So Dad's going to walk you through some of that as he talks. Spacing super important. That'll walk us through the spacing. Throw insulation in your cavity. It is not a violation of any UL design to put insulation in a partition design. And it's glass bat, faced or unfaced, doesn't matter. That gives you 4 to 5 points of STC right there. And if you can, that'll talk about double stud and staggered stud walls. Thicker the wall, the better it's going to perform, but we can't always do that. Our clients want every square inch. We want to caulk around the entire perimeter of the wall. You see the 3 pieces of drywall vertically installed. We leave a 1/4 inch gap around the edge and fill it with sealant. If they left that 1/4 inch gap and didn't fill it with sealant, we've defeated the whole purpose of doing this particular, spending money on a high STC wall. That sealant helps reduce vibrational energy on the floor and on the walls with doors opening and closing, right? Vibrate the walls from passing through. That's what we want to do. We want to make sure we're caulking these areas with an acoustical sealant or some kind of flexible caulk. Caulk both sides. The reason being is sound works both ways, just like most UL designs. If the daycare is on the left and the executive room is on the executive conference room is on the right, that works that way, or vice versa. Doesn't matter. You can put your sound assembly together any way you want. It's the way it's supposed to go. There's a purple soundboard there. It doesn't matter what side it's on, in other words. So sound will work both ways, but you got to caulk. Putty pads for our outlets. Putty pads will help prevent sound from penetrating through to the other side. Our electricians know how to get those. And of course, there's lots of options. We don't, as my company, we don't sell any of this stuff. But of course, you all are familiar with what they are, and there's plenty out there that can be purchased, specified. And I think the last but not least is offset our board joints. Any leaking of sound, any weak areas that sound can vibrate through easily, we just want to try to prevent that. Fire, UL wants you to do this anyway. And if it's a 2-hour wall with double layers, you're going to offset the vertical board joints of those as well. So we don't want board joints on top of board joints. And with that, I'll turn it over to Thad.
Thank you, Scott. We're going to talk now just about 3 primary building types and how we handle the solutions for them. What we see as gypsum manufacturers when people come to us with questions. While the sound transmission characteristics are consistent across all these categories, the priorities vary by different type. So this part of the presentation is basically kind of giving you a broad overview of those 3 primary building types, the structures we get, and the questions that we have. So as we think about this, we'll focus on 3 different types. We'll do healthcare, multifamily, and schools, which encompasses a big part of the built environment. We'll start with life safety because life safety is always the number one priority. Scott reviewed the most commonly used 1 and 2 hour rated assemblies that we see, and we'll make references to them as we go by, but understand that in each of these categories, those are the primary, probably 90–95% of what we see from requirements are in this 1 and 2 hour area that we've already seen. But to achieve these goals and meet the design intent of these different buildings, some of the priorities can be very different. Healthcare is a great example. If you just look at this wall, a lot of penetrations in this wall, a lot of things hanging on this wall. Anytime you create a penetration in the wall, that's a problem for sound. In addition, in a hospital, they're full of people, 24 hours a day, 7 days a week. There's open doors, there's nurses stations that have to be centrally located because we want to have close access to the customer. There's bells, there's whistles, there's alerts, there's alarms, there's things going on a regular basis. So sound penetration or sound protection in a wall with lots of penetrations is challenging. A big challenge for healthcare is protecting people from sound when they're at their most vulnerable. AIA uses the recommendations of FGI, and FGI has some very specific guidelines for what they do in open areas and closed areas. It's interesting when you think about this 35 that they have in the corridor areas as protection from a patient room in more of an open setting. There was a 2005 study of noise levels in hospitals at Johns Hopkins Hospital, and basically the noise level, the general noise level, exceeded 45. So while access to a patient is a primary concern, focused on adjacencies is one of the ways that we use to minimize sound overall. When we talk about adjacencies, here's another slide that goes into a little more detail. If you think about adjacency combinations with patient rooms, that's kind of the focus of what they do. If you're in an area with an open corridor, and I'm sure we've all been in those situations where we've either been in the hospital or gone to visit someone in the hospital, where they have a situation where maybe there's that glass sliding door, and so glass by itself is not super conductive to be able to control sound. But again, you have to have that line of sight in those critical care units and that patient visibility. So we think about all the activity that's happening. We think about all the different types of sound that goes in there. And then the other piece of the puzzle is we think about the types of surfaces that have to exist in a hospital. Basically, it has to be hard surfaces that are easy to clean and make sure that you can get them good and clean, because you have a variety of people that are coming in there that are sick, that are coming in time after time after time. You have different types of sicknesses that are there. So you have to be able to sterilize and still achieve some STC ratings. So in healthcare, we see these three common solutions in this order: mass, damped panels, and decoupling. And so we'll kind of talk about each one of these. The easiest way, as Scott looked earlier, one of the easiest ways to control sound is just add more mass. What Scott talked about earlier when he talked about the STC rating and how he says it's less useful if you go outside the parameters of that 125 hertz to 4,000 hertz. Well, think about the sounds in a hospital. There's a variety of sounds that are low volume, some of the MRI and some of those kinds of things that go on. And then you have their high sounds of some of the equipment and the bells and the whistles that are there that are way above 4,000 hertz. So the best way probably to get the increased STC values and the mass that you need right off the bat is to be able to add mass. The problem that you have is in hospitals, space is a huge concern. I mean, we're talking half inch, quarter inch. I mean, it's amazing how tight the system is when we start thinking about that. This particular graphic is a combination of something that our company publishes, and one of the people that I know that does healthcare on a regular basis. When we were putting this together, I reached out to some of the professionals that that I have. We talk about trusted advisors when you're an architect. As product reps, we have trusted architects, and so I reached out to a friend of mine who does primarily healthcare. And they basically have set up a couple different partition types. And this is their number one partition that they use when they're trying to meet those adjacencies that they need. Now, thankfully, as Scott said, you've got the mass of having some extra protection from sound in insulation. And now you've got your gypsum wall. And so in the areas where we need the adjacency protection, we can get there with a basic gypsum wall. Makes a lot of sense. We can meet those minimum requirements, and we can start down the road. When we get to the areas where we need to have a little higher, and in between those patient rooms, and we need to have a little higher STC, a thin wall example, a thin wall technology solution is a damped panel. I'm going to take just a minute and talk about it in case there's anybody on the line that doesn't have this information. A damped panel product, the damped panel technology has been around since the 40s. It was first used in submarines. Think about a submarine underneath the ocean, tremendous pressure on the outside. Anything that happens on the inside in that tin can would bounce around and reverberate many times. And it was a real problem for the Navy. And so they commissioned a firm to basically come up with a solution. And the solution was this. They put a viscoelastic polymer in between two layers. In that case, it was steel. In this case, it's drywall. They take two layers of something and they put a viscoelastic polymer in the middle of it. Now that polymer is kind of like tree sap. It never gets hard. And so what happens is, Scott talked about sound vibration. Sound vibrates through different materials and different mediums. When the sound starts to vibrate through this product, it's fighting two things. Number one is, this is a high density gypsum product. So it's about 2.9 pounds per square foot as opposed to the typical gypsum, which is 2.2, 2.2 for a regular type X gypsum. When it meets that dissimilar product in the middle, it confuses the sound, it alters the sound, the sound has to alter the way it moves. And so it flattens out what we call the coincidence dip. And I'm getting into a little level 201, 301 kind of area here with acoustics, but it flattens out the coincidence dip and helps dramatically with STC in that speech range that we're looking at, that we talked about. So thin wall technology. Here's a good example. In the previous slide, we saw 40 STC. The firm that I talked about earlier has identified the fact that they're going to do two things to help control sound and dramatically increase the STC rating of this wall. It's still a 4 7/8 inch wall, so your door throats would remain the same. You wouldn't have to get different sizes. Your mechanicals, your boxes and everything that was in the wall would all be able to remain the same. The two major changes are they've broadened out the studs so they have less contact points. We went from 16 on center to 24 on center, and then we've added the damped panel as part of the process. So those two changes together have solved the problem of getting to that 50 STC that we need for those patient rooms and those more stringent adjacencies. We're actually into the 55 range, which we'll see why that's important here when we talk about the difference between field testing and sound test and lab testing. Another option, which is a little less popular, but still very well received, is when we talk about decoupling. It's more predominant in other areas, but it's also good here. One of the situations that we have here is we traditionally see metal stud, and it's tougher to decouple metal studs because the open flange in that track has to be supported. So we use strapping as an additional tool. And then of course, when we use strapping, we've stiffened up the wall. So the overall minimal gain that we get from STC is fairly small. The best way to do that is to use a 2.5 inch stud, to use a smaller stud, create a separation. So you still have your little decoupling that's going on there to keep the decoupled walls as thin as possible. So you've got separate tracks, you've got a little bit wider wall, but you've dramatically increased your STC. So from hospitals, every single system that we've talked about here is basically meets those 1 and 2 hour requirements that we have, that we need. Means of egress, being able to get people out of the building, getting that protection that you need. Now, there are areas of the hospital where you will have more privacy concerns, more sensitive conversations. more HIPAA requirements. MRIs are a good example. Those are rooms, as we saw on the FGI chart earlier, that need to be significantly higher than 50. In those cases, we're not going to go through that today because of time constraints. In those cases, we ask that you reach out to your local construction design manager, your local gypsum rep, call the 1-800 number. We'll be happy to get you there. Wood frame construction. In wood frame construction, which has been hot, by the way, for over a decade and will continue to be based on the numbers that we see with multifamily challenges and things going on with the kind of growth that we're seeing in the United States. We're going to focus a little bit on the commercial, on the steel frame commercial, but we're going to spend most of our time on the wood frame challenges that we see in this particular segment. There are 3 different guidelines here, a couple different ways that people look for things. One is HUD, okay, and HUD is got their own rules. They've, as we typically know, everything they do, they pretty much have their own system where they go through things. They talk about nighttime dB levels, which, as Scott said, don't exactly match up to STC points 1 for 1, but they break it into minimum levels, which that minus 55 dBA is about, that signifies a quiet neighborhood in the evening. We've got average, which is something a little louder than that. And then the luxury would be like listening to a refrigerator running in the middle of the night. That's the only sound you would hear. So it's pretty quiet. And then they also talk about ICC ratings. And so, as Scott said, we talk about when we get into multifamily, we've got people above us, below us, beside us. So we have demising walls, and we have, you know, up above and below people that are there as well. So we need to have that floor ceiling situation covered as well. IBC and IRC specifies ratings that are 50 tested in the lab and 45 if tested in the field. For years, the IIC was very easy to accomplish because we just put carpet on the floor. With the direction with the luxury vinyl tile and some of the other, the wood frame and the wood flooring that's going on right now, it's much more of a challenge than it used to be. But here's where we start to see the separation between what happens in the lab as opposed to what happens in the field. So just know that both of these, there's not a lot of verbiage. I think it's like 2 paragraphs in each one of those, but there are minimum requirements that are out there for both of these code bodies. The International Code Council has actually thrown their toe in the water. In 2010, they came out with what they said was the guideline for acoustics, and that was a white paper. Typically, the way this happens is that, you know, the International Code Council sees they might want to get more involved somewhere, and they start to work through things, and they'll throw out a white paper, maybe have some dialogue, and eventually things work their way heavier into the code. This hasn't happened yet, although there's been, like I said, there's been changes in the FGI guidelines, there's been lead changes, there have been several other guidelines that have come out that have kind of hampered the progress on this one. But just understand a couple things here. Code minimum is still that 50. So that 50 is that kind of that magic number that we're talking about. And then they also have an acceptance and allowance similar to what we saw in the IBC and the IRC for field testing, because everybody understands what happens in the perfect setting of a lab is a little different than what's going to happen out in the field where buildings move and there's different parts of construction joined together. But they break it down into acceptable performance and even preferred performance. And so as we start to work their way up, like Scott said, the difference in STC, it's logarithmic. So the higher the number, the harder it is to get to. So to go from a 50 STC to a 60 STC is a pretty heavy lift, especially in wood frame construction. So common solutions for multifamily, you know, the easiest thing, the best thing, the thing we see most often is just to decouple. It's a stiff system. And so we want to decouple it and get as much of these parts away from each other as possible. Double and staggered studs, mass, and then occasionally a damped panel. So these are kind of the hierarchy of how the changes are made. When we think about decoupling, the most common thing that we think about is an unbalanced RC1 system. And if you look at the picture in the bottom right, what would happen would be the other side of that assembly would have 2 layers of drywall on it. You've got 2 layers of drywall on one side, which is more mass. You've got 1 layer on this side that's decoupled, so it's farther away from the studs and it's got less contact points. And in this case, we've used a combination of 2 of those things that we talked about to stop sound, is mass and space. This is a nice system. It works very well. It does a great job, assuming that everybody does their job at the front end of the job and the back end of the job. Now, we can control the front end. You know, we bid the project out, we get the right guy on the job, we monitor with our CA work, we make sure everybody's doing what they're supposed to. We get the building handled over to the owner and we do it perfectly. And then we hand the keys over to the owner. And sometimes that's when the problems start. You know, you're going to hang a big screen TV, you're going to hang bookshelves, you're going to hang pictures on the wall. The first thing the homeowner is going to do is they're going to find a framing member and they're going to drive a screw right into it, which can sometimes, most of the time, will short circuit the RC1 and the effectiveness of it. So that's the front end of the job versus the back end of the job. Good system, as long as there's educated owners that know how to use it. The very best way to control sound is to just basically keep those building components apart. So if we have a 1 inch or a 2 inch airspace and we have double stud walls, this is the very best way to achieve like what we consider to be luxury STC ratings. Now, sadly, it's also taking up the most amount of real estate, and it's also the most expensive wall that's out there. So in this particular case, it's one that this owner has to have a budget for. Some of the ways that they do that, if they don't have the budget for that total 9 inch space in between units, is they'll use a 2x6 header and footer, and they'll stagger the studs in between. That's less effective overall, but still very effective to get us to that 50 STC that we're trying to find. Ultimately, mass is important, and we're going to use an example here that's metal stud as we think about the fact that we're trying to make sure that we cover some of the commercial areas as well. Even in the high rises, when I travel Chicago, the high rises that I go into and see on a regular basis, their demising walls are basically this system here. 25 gauge metal studs, 24 inches on center, gets us into that mid 50 range. We've got less contact points, we've got more mass. Fantastic opportunity. In the wood frame construction, sometimes it's a little more difficult, but it can be done. Here again, the damped panel solution is one that we find that makes sense. We widen the studs out to that 24 inches on center with the 2x4s, and we put the damped panel on one side. We can still meet that minimum 50 that we need, and we haven't used a lot of space. So again, when you think damped panel, think about the fact that this is thin mold technology. So as we think about multifamily fire and sound priorities, you know, we have corridor and stairways and demising walls that tend to be that 2-hour protection. So we talk about that workhorse assembly that we saw earlier, that 2-hour protection. Those are the areas where we tend to see that. Area separation walls, like the picture we have here, every other unit would have an area separation wall as well. So we're covered the means of egress from a fire rating perspective, but the sound priorities are a little different than they were in healthcare, because where healthcare people never sleep, you know, there's quiet times during the evening, but those sounds never stop. Here, we're focused on how do we make it as quiet as possible for those people that need to rest and recover for the next day? How do we give them that silent night that they need? Education. A lot of the, you know, we are going to meet the same STCs, but with a twist. First of all, quiet classrooms. You know, we talked earlier, one of Scott's first slides was about the fact that the more quiet you can have things, the more productive people are. LEED recognized this from the very start, and there's other sustainable programs that have these requirements as well, but we're going to talk about LEED just for a minute because they were the first ones to come out in their program and offer an acoustical point for performance, and that was in LEED 1, 2, and base. That was in the earlier versions of LEED. When we got to LEED 4 and 4.1, they basically applied that category to other areas as well. But from the very start, they understood that students hear differently than adults do. And so they've got different adjacency combinations for several different types of situations in addition to schools. But the primary focus of schools is ANSI. ANSI is the governing body that kind of sets the guidelines. And so again, we see this 50 that we focused on, you know, from the very start. And here for the first time, we see an outdoors requirement as well. And we'll talk about why that can be here in a second. Children need to understand what's being said. So NRC, noise reduction coefficient, the way sound bounces around in the room is as important as anything else that we do. So we need to control the sound from the outside, and we need to control the sound that's going on the inside as well. So we want to minimize the background noise. We want to minimize the reverberation time of the sound that bounces themselves out in the room. For example, if you're in a conference room, Scott talked earlier about being in a conference room, having bodies in the seats, carpet on the floor, nice soft ceiling tile. And when we talk in those kind of rooms, sound bounces around 2 to 2.5 times, and then it dies out. So it has to be loud enough that we can do that, but it doesn't, we understand that it's not an anechoic chamber by any means, but it's basically a good reverberation point that everybody understands each other. When you walk into a bathroom, all those surfaces are hard. They're designed to repel water, and your sound will bounce around 6 or 7 times there. And so there's times when maybe you're in the bathroom with somebody else, and all of a sudden you think somebody's really speaking loudly. It's because their voice is bouncing around differently in that case. So when we get to children, we want to make sure that we can have them understand exactly what we're trying to talk about when they're getting that instruction. So we're going to control the background noise to the best that we can have it. What is background noise? Background noise is anything that will confuse or will draw the attention of those young minds away from anything that maintains a level of such that could be distracting to the children. Airplanes, trains. You know, I went to school in elementary school where there was a train that went by on a pretty regular basis, a couple of times a week. And there wasn't a single time that every boy in the room didn't look over there and watch what was going on to see what was on it. You know, playgrounds, there's times where children have different playground times that they're active. And so you've got somebody in a class, you've got somebody that's outside the playground. That's very distracting to a young mind. With inside noises, mechanical rooms can have different pitches where we talked about. Plumbing can have different pitches where we talked about this differently than where we're going from that 125 hertz or below that 125 hertz or above that. So as we think about how we control sounds in schools, this is the first time that we see room placement as an option. You know, when you're designing a school, you have the opportunity to start to put the pieces and parts in places where they make sense. Where in a hospital, you've got certain rooms that have to be in logical places. Multifamily, they're all about the same. Then mass, and then we'll touch briefly on CMU and gypsum walls in the mass category. So here's an ANSI chart that kind of gives you an idea of what we're trying to do. We're trying to keep the dBA about 35 in the classroom so so the children can understand. And at the same time, we're trying to keep that 50 wall in between the two classrooms. When we get to things that are outside that area, like toilet rooms, mechanical rooms, cafeteria, music rooms, those sort of things, you know, we can put them, hopefully, we can move them as far away from the classroom areas and minimize the number of classrooms that are touched by this space. From an outdoors perspective, you know, outdoors on one side of the building, it's easy because you've got a hallway and you've got the interior of the building. When we think about the outside of the building, you know, we want a nice solid hard surface on the outside. And then of course, with the safety concerns and the energy concerns that we have with the glass that we have in buildings anymore, we naturally bend to more resilient products right there. So we tend to try to get an example of how we can see a 45 or better there, which is typically tough with glass, but a lot of the glass we use is much more expensive in schools. So for CMU walls, we tend to think of CMU walls as being very thick, very hard, but really the 8-inch block that we normally use is going to get you a 48. You can fill it with grout, you can fill it with sand, or in some cases, you've got the advantages to be able to put some sound deadening paint on one side or the other side that helps get you where you need to be in other wall coverings. CMU is still about 65 to 70% of the buildings for schools across the country. Makes a lot of sense, works well in those areas where you are going to use them as a structural component as well. And the additional cost with the durability and life of the building being 40, 50, 60 years, however long it lasts, is excellent for the taxpayers because they can get it paid off and still have a working, functioning building for a few years after that. In the 1990s, we came out with abuse and impact resistant drywall. So you've seen a move to more traditional type buildings. They're probably 25, 30, 35% of the buildings and schools that are built now are built with this type of a system. We've already been through several different walls. We're not going to spend a lot of time on this, but we have one question that we just wanted to address from sound perspective. We get the question all the time, if I have an abuse or impact resistant wall, how much more STC protection do I get than the regular gypsum wall that you've talked about earlier in this program? And the answer is very little. It's already a dense product. It's already a dense wall. That sound is a system assembly. So we have the stud spacing and we have the insulation as well there to help out. So if you think about, you could go with the same test just to be sure, you might get one extra STC point. So that's a common question we got. We just wanted to bring up here. So again, as we wrap up schools, speech intelligibility is important. Room placement is one way to control sound. Means of egress, the block walls that we talked about, the abuse and impact resistant walls that we talked about, all give you those 1 and 2 hour sound protections that you need. Again, when you have those increased sound protection areas, make a phone call to your gypsum rep. They'll help you out there. So just to kind of do a quick recap, multifamily, healthcare, and schools all have those same concerns about life safety, 1 and 2 hour protection, like we talked about in the very beginning of this program. For those areas where you need additional support in those areas, again, reach out to your 1-800-GYPSUM person and make sure that you get the protection that you need and you get all the help that you need from a sound and a fire perspective. Again, healthcare adjacencies is a focus, multifamily, floor ceiling and corridor and sound walls, and have those silent nights. If you got schools, we've got speech intelligibility and situations there. So hopefully this has given you a good idea of how we can start to think about these in a broad term, in a general term. And so sound protections are more, like Scott said, we get more questions about this now than we ever have in our history. So reach out to us if you need some help. We'll be happy to go there. So this concludes the AIA portion, and Scott's got a couple of things he'd like to wrap up with.
Thank you, Thad. So real quick, we'll introduce you some great resources that we have for you. National Gypsum Company is the exclusive service provider for these building products. Gold Bond is our drywall. Gypsum board. Permabase is our cement board. We have Dexel, which is our roof cover board, and we have Proform finishing products, which is all of our joint compounds. The first thing to show is the website. So nationalgypsum.com, super easy to remember. And you'll see a link at the top for our design and resource center. And everything we've talked about there today is there. So we've got, of course, product information, but more importantly, we've got specifications, we've got lead documentation. I say lead, but sustainable design, HPDs, all those kinds of things are found there. Fire design, STC ratings, and those kinds of things can all be found on our website. And I'm about to walk you through our resource books. They also can be found here that you can download to your computer. Don't forget about our human touch. Okay, so we've got the computer touch. We've also got the human touch. So at nationalgypsum.com/expert-connection. And we're going to send a follow-up email with that link. That's how you find us. So if you're in the Texas area or that central part, southwest part there in that white, and just reach out to Thad or myself. We're happy to help you out. 800-NATIONAL, very important phone number. Those three gentlemen there answer that line. That is our technical department. We call it our construction services department. They are available to help with the hard stuff. You know, the hard to find. I don't know what to do here. Don't waste time. Call us. We're willing to work with you. So here are our resources. In one slide, we've got 4 of them. The construction guide is brand new, hot off the press. And that has everything from drywall to cement board to IFP, which is our finishing products, to plaster, area separation wall information, fire, sound selectors, everything in one book. That's our construction guide. And then we've got 3 resources that kind of complement all of that. and we're going to walk you through those real quick. We'll stay on topic with sound. So the first is the sound book. If you have a sound book in your office and it doesn't say 2.0 on the front cover, recycle it and ask us. We'll send you a new one. The sound book covers all of our STC ratings. So we've got 120 pages full of tested wall assemblies with wood studs, with metal studs, with different thicknesses of stud, different gauges, including 18 gauge. And then, of course, different applications, chase walls, perimeter walls, all of those things, double stud walls, things that just we've covered it all. And what you see in the diagrams here, this is, obviously taken right out of our sound book. You've got this STC test, what was tested. You see the purple, that's our soundboard that I'll talk about in just a second. There are plenty without it though, so you can compare what does the soundboard really do to this assembly. So not every single assembly has the soundboard. UL references are also on every design. The purple book is the other topic today, which was fire. So this is a metal book. So it's all about metal construction, steel studs, and it covers all of the different applications, head of wall details, priority legends, how to intersect 1 and 2 hour fire rated walls, horizontal lids, corridors, elevators, shafts, shaft walls, all of those things, columns are in this book. And then what you'll see here is actually some pictures of what's in the book. Each page has its own design, and we cover our head of wall detail, if there is one, as well as what the UL references too. So all of that is found in our purple book. You can see on the right, if my partition doesn't line up with the beam, how do I fire stop it? Well, this is how you do it. The wood book is hot off the press as well. So it's another brand new resource. We think it's one of the best out there when it comes to UL fire rated designs and wood construction. It's the exact same thing as the purple book, except it's all wood. So the purple book is metal, wood book is wood, and it covers, again, head of wall details, area separation wall, shaft wall details, how to maintain a 1 hour rating through all the different floors, and it's just page after page of things like that. So it's another great resource, all available from your construction design manager via mail, or you can go to nationalgypsum.com and download it. Real quick, we're going to run through the products. XP is our purple product line. It is purple paper-faced drywall that has been treated for mold, mildew, and moisture resistance. We have XP, great for interior of exterior walls, basements, moist areas, not showers, not the shower itself, but once you step out of the shower, it's a great product for that. Thad mentioned Abuse and Impact. Abuse has a heavy-duty paper to it, so it's scuff resistant. Impact has a fiberglass mesh hidden inside it. It's a baseball bat stopper. So that we've got all of these offerings in our XP line, including Soundbreak XP. My next slide will dig into that. So it's and then we have a shaft liner product that's also treated for mold and moisture resistance. So the Soundbreak product is what you saw throughout the presentation today, 2 layers of drywall, viscoelastic polymer, like Thad mentioned. We make it in 5/8 type X, so you can use it in UL fire rated assemblies. It is abuse resistant, so it has that heavy duty paper. It qualifies as abuse resistant under ASTM C1629. It's purple, that means it's moisture and mold resistant. And all of our interior products are gold, Green Guard Gold certified. So just another little benefit of specifying that product. We also have a fiberglass mat line of products. The advantage of fiberglass mat is you'll get an exposure warranty to them. So we're most familiar with the sheathing, that upper right picture. The purple sheathing you see all around town. That's been around for quite some time, but we also have interior drywall that's fiberglass mat so that you can hang it in the building, pre-rock conditions, before the windows are in and before the roof is tight, and we'll guarantee that it'll be usable for up to 12 months of exposure. Now, it can't be sitting in a puddle of mud on the job site, but if it's hung, because there's no paper to delaminate, it works real well. So there's a whole line of those products there. Dexel roof boards, we have cover board for flat roofing, low slope roofing. We've got various versions of it depending on what application. So is it a single ply? Is it a glue, torch, mopped roof? We've got a lot of options here for protecting your insulation on the roof. Perma base is our cement board on the left, a tile backer, various thicknesses and sizes for use as a tile backer. On the right, a product that's been out about 5 or 6 years now. It's taking off like gangbusters. It's cement board laminated to polyiso. various thicknesses to meet the continuous insulation requirements depending on what zone your project is in. So it's a great option. Stick it on the wall. You've met your continuous insulation, and now we can adhere thin stone, thin brick, or a stucco to it. So real quick, real easy to install. And of course, being a gypsum manufacturer, we've got all of the finishing products, whether it's ready mix or a setting compound. So more of a contractor preference with all those colors. So for architects, we don't care as much. The contractors do have different weights that they enjoy those kinds of things. On our website, Design Center website, you can get access to all of our Green Guard certs, our HPDs, EPDs, declare labels for the various products we have, all in one-stop shop. And Jordy Polk is also a great resource. Introduced her in the beginning for help with those things too. Of course, specifications available on the website, like any manufacturer, and we are readily available in Product Master Spec and Spec Link. Folks, thank you. Went a minute over, but thank you so much for spending an hour with us. We are going to follow up with an email, so you'll get links and things to all the things we've talked about today. Enjoy the rest of your day.